Okay, so today we're doing a deep dive into some pretty heavy stuff. We're going to be exploring the logic of Bernard Bolzano, and we're going to be using the Stanford Encyclopedia of Philosophy as our main source here.
All right, sounds good.
Yeah, this one's for our listeners who really like to get into the nitty gritty, the nuts and bolts of how knowledge and reasoning work.
Oh,
So
yeah.
yeah, if you're into that kind of thing, this is going to be right up your alley.
Yeah, and Bolzano is a great example, I think, for anyone who's concerned about the architecture of logical systems and, how truth and consequence sort of fit together. And the amazing thing is that he was writing in the 19th century, but his work still feels so relevant today.
Yeah, that's what's so cool about this stuff, right? Like, it's not just like, oh, let's dust off some old books and see what they said. It's like,
Yeah.
these are ideas that are still being grappled with. I mean, the Accept P entry even mentions a contemporary logician who reviewed Bolzano's theory of science. Like, it was brand new and was blown away by it.
Yeah, that's wild.
Yeah, it really is. And so, Bolzano, he was definitely influenced by those 18th century debates,
Mhm.
but there's this real sense of him like pushing forward, with his anti-psychologism and his work on semantics. It's really ahead of its time.
Yeah, so I think we should start by looking at his theory of science. That's sort of the main event here. But before we get there, it might be helpful to look at some of his earlier work, like his 1810 booklet, Contributions to a Better Founded Presentation of Mathematics.
Okay, yeah. What was he up to there?
Well, so right from the start, you can see that he was dissatisfied with the way math was being done. He wasn't content with just like working through the theorems and the proofs. He wanted to understand the like fundamental nature of mathematics, like what is it really about?
So he wasn't just like, okay, how do we do math better?
Mm.
He was asking like, what is math? Like, what are we even doing here?
Exactly. And so in this booklet, he proposes this new definition of mathematics as the science dealing with the general laws of existence. And that's a pretty huge claim. He's basically saying that math is not just about numbers and shapes, it's about the very structure of reality.
Wow. Okay, so and he saw logic as being like really closely tied to this?
Oh yeah, absolutely. He considered logic to be like the essential method for rigorous mathematical inquiry. It's like the tool you need to really understand those general laws of existence.
Okay, so that makes sense. And this idea of like rigorous inquiry, it reminds me of one of the key things that he talks about in Contributions, this distinction between certifications and groundings.
Oh yeah, that's a good one. So basically he's distinguishing between like proving that something is the case versus explaining why it's the case. Like you can prove that the Pythagorean theorem is true, but that doesn't necessarily tell you why it's true. Like what's the underlying reason?
Okay, so it's like the difference between like being able to like check a math problem and getting the right answer versus like actually understanding the concept.
Right. And that's something that still resonates today. Like in the philosophy of science, for example, there's a lot of discussion about what makes a good explanation. Is it enough to just have a theory that predicts the data, or do we need something more? Do we need to understand the underlying mechanisms? And I think Bolzano's distinction between certifications and groundings is really relevant to that debate.
Yeah, that's cool. And it seems like he was also thinking about these issues in terms of definitions and axioms. Like, how do we know if a definition is a good one or an axiom is a true one?
Yeah, so for Bolzano, definitions weren't just like arbitrary labels that we attach to things. They were supposed to reflect the objective components of a concept. And similarly with axioms, he didn't see them as just like self-evident truths that we have to accept without question, but rather as objectively fundamental truths that are like the building blocks of a deductive system.
So it's like he's looking for this objective structure underlying both math and logic.
Yeah.
Like there's this architecture that's out there waiting to be discovered.
Exactly. And this has some really interesting implications for epistemology too. Like how do we know what we know? So Bolzano recognized that like axioms don't have to be immediately evident to us. Our conviction in their truth can come from seeing how they fit into a coherent deductive system. Like if they lead to established truths and they don't produce contradictions, then that gives us good reason to believe in them.
So it's like it's not just about like, oh, this feels intuitively true. It's about how it all hangs together.
Right. And he also had this fascinating idea about how we can grasp simple concepts, which he called paraphrases or circumscriptions. And basically the idea is that we can understand a concept by seeing how it's used in different sentences, by seeing the different ways that it can be combined with other concepts.
So it's like understanding a word by looking at its different uses in a dictionary, like all the different contexts that it can appear in.
Yeah, exactly. And he also applied this idea to proofs. He was already thinking about what makes a proof valid, and he came up with two main criteria. One is that the proof has to use all the characteristics of the subject matter. You can't just pick and choose the parts that you like. And the second criterion is that you can't cross genera. You can't use concepts from one domain to prove something in a completely different domain. And he uses the intermediate value theorem as an example of this.
Okay, so he's laying the groundwork for a really rigorous and systematic approach to logic and math.
Absolutely. And these early explorations, they kind of set the stage for his magnum opus, the theory of science, which he finally published in 1837.
Okay, so the theory of science, this is where he, like, lays out his whole system.
Yeah, and it's a really ambitious project. It's not just about logic, it's about epistemology and the methodology of science. Like, how do we acquire knowledge? How do we organize it into a coherent system? And he even defines the theory of science itself as the set of rules for dividing knowledge into different disciplines and for composing scientific treatises.
So he's not just talking about the content of science, he's talking about the very structure of science.
Exactly. And he proposes this hierarchical structure for the different disciplines of science, starting with the theory of fundamentals, which establishes the existence of propositions and ideas in themselves. And then we have the theory of elements, which is the core of his formal logic. And then the theory of knowledge, then heuristic, which is the art of discovery. And finally, the theory of science proper, which is about how to organize all this knowledge into like a comprehensive scientific treatise.
Okay, so the theory of elements is where we get, like, the nitty-gritty logic stuff.
Yeah, and one of the most important things about Bolzano's logic is that it's anti-psychologistic.
Mm.
He rejects the idea that logic is just about how we think.
Right, so instead of focusing on, like, the psychological processes of reasoning, he's interested in the objective relationships between propositions and ideas.
Exactly. He's saying that logic is about truth and falsity, and about how propositions and ideas connect to each other independently of any particular mind that might be thinking about them. And this is a really radical move. It sets him apart from a lot of his contemporaries, and it really paves the way for modern analytic philosophy.
Okay, so that makes sense. But how does he actually define a proposition? Like, what is a proposition in itself?
So he doesn't actually give a formal definition of a proposition in itself, but he uses this method of circumscription to sort of convey what he means. And basically he says that a proposition in itself is the meaning of a linguistic expression, and it's either true or false, and it's non-actual meaning. It doesn't exist in time or space, and it's distinct from the act of thinking the proposition or the particular linguistic expression that we use to express it.
Okay, so it's like the content of a sentence, but it's not tied to any particular sentence.
Right. And he uses this phrase in itself to indicate that we're talking about something that's completely general. It's not tied to any particular language or any
Yeah.
particular mind.
And he believes that these propositions in themselves actually exist.
Yeah, he thinks that they exist objectively, kind of like mathematical objects. Like the number two exists whether or not anyone is thinking about it. And so he says that propositions in themselves exist, but they're not actual, meaning they don't have causal powers or anything like that.
Okay, so they're like abstract objects.
Right. And to distinguish these abstract propositions from the sentences that we use to express them, we're going to use square brackets, So we'll write like Socrates has wisdom to refer to the proposition in itself.
Okay, so that makes sense. Now, you mentioned that Bolzano's logic is anti-psychologistic, but it still seems like he's paying attention to the structure of language, like the way that sentences are put together.
Yeah, that's true. I mean, he recognized that language can give us some clues about the structure of propositions, even though propositions themselves are not linguistic entities. And so he uses this example of the sentence, Romeo loves Juliet. And he points out that we can replace certain parts of this sentence with other words and still get a grammatically well-formed sentence, so we can replace Romeo with Hamlet or Juliet with Ophelia and so on.
And so he's saying that we can do something similar with propositions in themselves.
Right. So even though propositions don't have like physical parts or anything like that, we can still think of them as having constituent ideas that are arranged in a certain way, and we can consider what happens when we vary those constituent ideas.
Okay, so this is his idea of propositional forms.
Yeah, so by treating certain parts of a proposition as variable, we can generate a whole class of propositions that share the same structure, but differ in the specific ideas that occupy those variable positions. And he actually makes a distinction between propositional forms and classes of propositions. He says that, strictly speaking, propositional forms are the sentential forms that determine these classes, not the classes themselves.
Okay, so it's like the blueprint for the class.
Right. And he also points out that a sentence doesn't have to perfectly correspond to the proposition that it expresses in order for us to identify these variable parts. The
Yeah.
crucial thing is that the replaced parts of the sentence correspond to the right parts of the proposition.
So it's like we can still use language as a guide, even though it's not a perfect mirror of the proposition?
Right. And because different parts of a proposition can be considered variable, a single proposition can belong to multiple forms. There's not a one-to-one correspondence between propositions and forms.
And so what are the basic building blocks of these propositions? What are they made of?
Well, he calls them ideas, and he defines an idea as any constituent of a proposition that's not itself a proposition.
Okay, so in the proposition Socrates has wisdom, the ideas would be Socrates and wisdom.
Exactly. And just like with propositions, he makes a distinction between ideas in themselves, the thoughts that we have in our minds, and the linguistic signs that we use to represent those ideas.
So the word Socrates is not the same as the idea Socrates.
Right. And the Sessa points out that Bolzano's use of the word idea is actually quite different from how other philosophers were using it at the time. It's closer to what Husserl called part meanings or what Frege called senses.
Okay, so these ideas in themselves, they're not just like mental images or concepts in our heads, they're objective entities.
Yeah, and he gives them these objective characteristics. He says that every idea that refers to an object has three main features: its extension, its content, and its structure.
Okay, let's break those down. What's extension?
Extension is just the collection of all the objects that fall under that idea. So the extension of the idea dog is the set of all dogs.
And what about content?
Content is like the sum of the parts of an idea, but without regard to their arrangement. So for example, the idea even prime number and the idea positive square root of 4, they both have the same extension, which is just the number 2, but they have different content because they're made up of different constituent ideas.
Okay, and then structure is how those constituent ideas are arranged.
Right. So for example, the idea the father of Socrates and the idea the son of Socrates, they have the same content. They're both made up of the ideas father, son, and Socrates, but they have different structure because the ideas are arranged differently.
And Bolzano says that all complex ideas are ultimately composed of simple ideas, right?
Yeah, that's his principle of semantic atomism. He thinks that every idea can be broken down into these simple, indivisible parts. And he says that simple ideas that refer to objects, they have no content or structure. They're just individuated by their extension.
So it's like the most basic unit of meaning.
Right. And the ST mentions that there's a bit of a problem with his account of simple ideas that don't refer to objects. Like how do you individuate those?
Okay, that's interesting. But let's move on to how he classifies ideas. He talks about objectual and objectless ideas, right?
Yeah, so objectual ideas are ideas that refer to one or more objects, like the idea dog or the author of the theory of science, and objectless ideas are ideas that don't refer to any objects, like the idea round square or the idea not.
Okay, and he says that objectless ideas have no extension.
Right, because there are no objects that fall under them.
And then he also distinguishes between singular and general ideas.
Yeah, singular ideas refer to exactly one object, like the idea, the current president of the United States, and general ideas refer to more than one object, like the idea dog or the idea planet.
And he uses the term intuition to refer to simple singular ideas, right?
Yeah, he borrows that term from Kant, but he uses it in a slightly different way. For Bolzano, intuitions are like our most basic grasp of individual objects. And he contrasts intuitions with concepts, which are ideas that are not intuitions and don't contain any intuitions as parts.
Okay, and then mixed ideas are ideas that contain both intuitions and concepts.
Right, and he sees intuitions as being really important for empirical knowledge. He thinks that any singular idea of a contingent particular has to contain at least one intuition because that's how we connect our concepts to the world.
And this distinction between intuitions and concepts is also related to his distinction between a priori and a posteriori judgments.
Yeah, so he defines an a priori judgment as one that can be derived from purely conceptual propositions, and an a posteriori judgment as one that depends on intuitional propositions. So a priori judgments are based on reason alone, and a posteriori judgments are based on experience.
And he thinks that there are some sciences like math that are purely conceptual.
Yeah, he thinks that fields like number theory and real analysis, they don't rely on any intuitions. They're just about the relationships between concepts.
Okay, so that's a lot to take in. But let's move on to how he relates these ideas to each other. He develops this thing called the extensional logic of ideas, right?
Yeah, so this is basically a logic of classes. It's about how the extensions of different ideas relate to each other.
Okay, and he was influenced by this guy named Moss.
Yeah, J.G.E. Moss. He wrote this book called Outline of Logic, And Bolzano was really impressed by it, and so he builds on Moss's work to develop his own system of relations between the extensions of ideas.
Okay, so what are some of these relations?
Well, the most basic one is compatibility, which means that two ideas have at least one object in common. So the ideas dog and mammal are compatible because there are dogs that are also mammals.
Okay, and then incompatibility is the opposite of that.
Right, so two ideas are incompatible if they have no objects in common. So the ideas dog and cat are incompatible because there's no such a thing as a dog that's also a cat.
And then he defines a bunch of other relations based on compatibility and incompatibility.
Yeah, so we have inclusion, which means that all the objects that fall under one idea also fall under another idea. So dog is included in mammal because all dogs are mammals.
Okay, and equivalence means that two ideas have the same extension.
Right, so equilateral triangle and equiangular triangle are equivalent because every equilateral triangle is also equiangular and vice versa.
And then there's subordination, which is like inclusion but not equivalence.
Right, so dog is subordinate to mammal because all dogs are mammals, but not all mammals are dogs.
Okay, and what about overlapping?
Overlapping means that two ideas are compatible, but neither one includes the other. So dog and pet are overlapping because some dogs are pets and some pets are dogs, but not all dogs are pets and not all pets are dogs.
Okay, so that covers compatibility and its derivatives.
Yeah.
What about incompatibility?
Well, he further divides incompatibility into three kinds: mutual exclusion, contradiction, and contrariety.
Okay, so mutual exclusion is just the basic idea of incompatibility.
Right. Two ideas are mutually exclusive if they have no objects in common.
And contradiction means that one idea is the negation of the other.
Exactly. So dog and non-dog are contradictory because everything is either a dog or a non-dog.
And then contrariety is like incompatibility but not contradictory.
Right. So dog and cat are contrary because they're incompatible, but they don't exhaust all the possibilities. There are other things besides dogs and cats.
Okay, so that's a pretty detailed system of relations.
Yeah, and Bolzano actually envisions them as forming this kind of genealogical tree, with the most general idea at the top, and then branching down to more and more specific ideas.
And the SE points out that we can actually formalize all of these relations using set theory.
Yeah, that's right. So we can define compatibility as the intersection of two sets being non-empty, and incompatibility as the intersection being empty, and so on.
Okay, so now we've got ideas and we've got these relations between their extensions. What about propositions? How does he analyze those?
So he starts from this idea that every proposition has a finest form, a form where every simple idea is independently variable.
And this is based on his semantic atomism, right?
Exactly. He thinks that every proposition can be broken down into these simple ideas, and that each of those ideas can be varied independently of the others. But he also recognizes that this is a really difficult task, to actually define all the possible propositional forms because there's so many different ways that ideas can be combined.
Yeah, it seems like it would be almost impossible to come up with a set of rules that could generate all the possible sentences in a language, let alone all the possible propositions.
Right. And so he takes a different approach. He works from the outside in. He starts with existing propositions and he analyzes them as needed.
Okay, so instead of trying to build propositions up from scratch, he's like taking them apart and seeing how they work.
Yeah, and because propositions themselves are causally inert, they don't do anything in the world, he has to rely on linguistic expressions and thoughts to guide his analysis.
Right, so he's using language as a tool to understand propositions.
Exactly. And he recognizes that language is not always a perfect guide. Like sometimes we use words in ways that are not logically precise.
Yeah, like when we say the sun rises, we don't really mean that the sun is literally moving up in the sky.
Right, but he thinks that even though language can be messy, it can still give us some clues about the structure of propositions. And so he proposes this really bold claim. He says that every proposition can be expressed in the subject-predicate form.
Okay, so he thinks that every proposition is basically saying that something has some property.
Yeah, and he understands this form in a pretty broad way, so the subject doesn't have to be a single object. It can be a collection of objects, and the predicate doesn't have to be a simple property. It can be a complex relation. And he even tries to fit relational claims into this subject-predicate mold by interpreting them as statements about collections.
Okay, so it's a very flexible framework.
Yeah, and he uses this framework to define truth. He says that a proposition of the form A has B is true if and only if A actually has B.
Okay, so that makes sense. But how does he handle existential claims like there exists a dog?
Well, he analyzes those as saying that a certain idea has objectuality. So there exists a dog. means that the idea dog has objectuality.
Okay, and what about negative existentials like round squares don't exist?
He analyzes those as saying that a certain idea lacks objectuality. So round squares don't exist means that the idea round square lacks objectuality.
Okay, so that's a neat way to handle non-being.
Yeah, and he also distinguishes between objectuality and actuality. So he says that mathematical objects like numbers, they have objectuality, but they don't have actuality, meaning they don't exist in space and time or have causal powers.
Okay, and then he also distinguishes between predicate negation and propositional negation.
Yeah, predicate negation is when you negate the predicate of a proposition. So Socrates is not wise is a predicate negation of Socrates is wise, and propositional negation is when you negate the whole proposition. So it's not the case that Socrates is wise is a propositional negation of Socrates is wise.
Okay, and he says that these are not equivalent.
Right. And he also gives these really interesting paraphrases for material disjunctions, like A or B. He tries to analyze those in terms of the objectuality of a true proposition within a collection.
Okay, so he's really trying to like systematize all the different logical operators.
Exactly. He's trying to develop a comprehensive framework for understanding how propositions are structured and how they relate to each other.
Okay, so now we come to what the SP calls his major innovation, the logic of variation.
Yeah, this is where things get really interesting. So instead of just analyzing individual propositions, he starts to look at how propositions change when we vary their constituent ideas.
Okay, so it's like he's introducing variables into logic.
In a way, yeah. But he's very careful to distinguish between what's going on at the level of language and what's going on at the level of propositions themselves. So he uses sentential forms with variables like X is a dog to illustrate his ideas, but he's clear that at the level of propositions themselves, there are no variables.
Right, so it's like a conceptual tool.
Exactly. It's a way of thinking about all the different propositions that share a certain structure.
And this leads to his definitions of universal validity and universal invalidity.
Yeah, so a proposition is universally valid relative to certain variable ideas if all the permissible substitutions for those ideas result in a true proposition.
So like X is a dog or X is not a dog would be universally valid.
Right, because no matter what you substitute for X, the proposition is always true.
And then universal invalidity is the opposite.
Right, so a proposition is universally invalid if all the permissible substitutions result in a false proposition.
Okay, and then he also defines a degree of validity.
Yeah, which is the ratio of true variance to the total number of permissible substitutions.
Okay, so it's like a measure of how likely a proposition is to be true.
In a way, yeah, but it's important to remember that this is still a purely logical notion. It's not based on any empirical evidence.
Right, and then he also has this really interesting take on analyticity.
Yeah, he borrows that term from Kant, but he gives it a completely different meaning.
Okay, so what's his definition?
He says that a proposition is analytic relative to certain variable ideas if it's either universally valid or universally invalid relative to those ideas.
Okay, and his justification for this is different from Kant's.
Yeah, Kant's idea was that analytic propositions are true by virtue of the meaning of the terms involved, like all bachelors are unmarried, is true because the word bachelor means unmarried man, but Bolzano's definition is based on the idea of truth invariance under substitution. So if the truth value of a proposition stays the same no matter what you substitute for certain ideas, then those ideas are not really contributing to the truth of the proposition.
Okay, so it's like they're logically inert.
Right, and Bolzano's definition of analyticity is much broader than Kant's. It includes a lot of mathematical truths, for example.
And he also distinguishes between logical analyticity and general analyticity.
Yeah, logical analyticity is when the only invariable parts of a proposition are logical concepts like and, or, and not.
Okay, and general analyticity is when there are also non-logical concepts that are invariable.
Right, and the SEPI mentions that there are some interesting parallels between Bolzano's notion of logical analyticity and later work by Ajdukiewicz, Carnap-Quine, and Tarski.
Okay, so he's really anticipating a lot of the ideas that would become central to analytic philosophy.
Absolutely. And it's important to note that for Bolzano, analyticity doesn't entail necessity or a priority. He thinks that there can be contingent analytic propositions.
Okay, so that's a big difference from Kant.
Yeah, and it also means that his definition of analyticity is not really about the relationship between meaning and truth in the way that Kant's definition was.
Okay, so now we come to how he applies this logic of variation to relations between propositions.
Yeah, so he wants to develop a system for understanding how different propositions with shared variable ideas relate to each other. And this is very similar to what modern logic does. Like when we talk about logical consequence, we're talking about how the truth of one proposition guarantees the truth of another proposition.
Okay, so he's basically trying to formalize the notion of logical consequence.
Yeah, but he does it in a way that's quite different from how modern logic does it. He doesn't rely on a distinction between logical and non-logical constants, and he uses this notion of verifying ideas.
Okay, what are verifying ideas?
So verifying ideas are just the substitutions for variable ideas that make a proposition true.
Okay, so if I have the proposition X is a dog, and I substitute Fido for X, then Fido is a verifying idea.
Right, and Bolzano uses this notion of verifying ideas to define compatibility between propositions.
Okay, so how does that work?
He says that two propositions are compatible relative to certain variable ideas if there's at least one set of verifying ideas that makes both propositions true.
So, for example, X is a dog and
Yeah.
X is a mammal are compatible because I can substitute Fido for X and both propositions will be true.
Exactly, and then he uses compatibility to define deducibility.
Okay, so how does that work?
He says that a set of propositions M is deducible from another set of propositions. A relative to certain variable ideas if two conditions are met. First, the combined set of A and M has to be compatible. And second, all the verifying ideas for A have to be verifying ideas for M as well.
Okay, so it's like saying that if the premises are true, then the conclusion has to be true.
Exactly. And he gives this really nice analogy. He says that compatibility between ideas is like having at least one object in common. And compatibility between propositions is like having at least one verifying idea in common.
Okay, that makes sense. And then he goes on to define all these other relations between propositions based on compatibility.
Yeah, so we have inclusion, which means that the verifying ideas for one proposition are a subset of the verifying ideas for another proposition.
Okay, and equivalence means that two propositions have the same verifying ideas.
Right. And subordination, overlapping contrariety, and contradiction, they all have their analogs in the realm of propositions.
And the SE shows how we can formalize all of this using set theory.
Yeah, that's right. So we can represent propositions as sets of verifying ideas, and then we can define all these relations in terms of set theoretic operations.
Okay, so that's pretty neat. But what about probability? How does that fit into all of this?
So Bolzano actually integrates probability into his logic. He defines the conditional probability of a proposition M relative to another proposition A as the ratio of the number of verifying ideas for both A and M to the number of verifying ideas for A alone.
Okay, so it's like a measure of how likely M is to be true, given that A is true.
Right. And because his definition of deducibility requires compatibility, the denominator of this ratio can never be zero, which means that deducibility can be seen as a special case of probability where the probability is 1.
Okay, so deducibility is like the limit case of probability.
Exactly. And incompatibility is the other limit case where the probability is 0.
And the SEP says that this is the first logical definition of probability.
Yeah, it's a really remarkable achievement, and it shows how Bolzano was trying to bridge the gap between deductive and inductive logic.
Okay, so now let's talk about how Bolzano's notion of deducibility compares to modern notions of logical consequence.
Yeah, so Bolzano's approach is quite different from the way that modern logic defines logical consequence. Modern logic typically relies on a distinction between logical and non-logical constants, and it defines logical consequence in terms of truth preservation across all possible interpretations.
Okay, and Bolzano doesn't do that.
Right. He doesn't have this distinction between logical and non-logical constants, and he defines deducibility in terms of truth preservation across all permissible substitutions for variable ideas.
Okay, so this is a more general notion.
Yeah, and it means that deducibility is a triadic relation. It holds between premises conclusions and a specific set of variable ideas.
So it's not just about the propositions themselves, it's also about which ideas we're considering to be variable.
Right, and this allows Bolzano's notion of deducibility to capture a wider range of inferential relationships than modern notions of logical consequence.
Okay, and he also has this idea of exact deducibility.
Yeah, so exact deducibility is when a conclusion is deducible from a set of premises, and it's not deducible from any proper subset of those premises.
Okay, so it's like eliminating redundant premises.
Right, and then he also defines logical deducibility, which is when all the invariable elements in a deduction are logical concepts.
Okay, and the SE says that this is similar to Tarski's notion of logical consequence.
Yeah, there are definitely some similarities, but there are also some important differences. Tarski's approach is model theoretic, whereas Bolzano's approach is substitutional.
Okay, so they're coming at it from different angles.
Right. And Tarski's approach is ultimately more powerful because it doesn't rely on this assumption that every object has a unique representing idea.
Okay, so we've covered a lot of ground here.
Yeah.
But there's one last thing that I want to talk about, Bolzano's theory of grounding.
Yeah, the abfolge. This is another really important part of his work.
And the SAP says that it's the first modern systematic study of axiomatic systems.
Yeah, that's right. So Bolzano is trying to understand how truths are grounded in other truths, like what makes a truth true.
And this is connected to his earlier ideas about the objective connection among truth.
Yeah, so in Contributions, he talks about this distinction between certifications and groundings. And he says that grounding is about explaining why something is true.
This theory of grounding.
Right, and he introduces this relation of ground-consequence, which he calls abfolge.
Okay, and he says that this relation is different from deducibility.
Yeah, deducibility is about truth preservation. If the premises are true, then the conclusion has to be true. But grounding is about explanatory priority. The ground explains the consequence.
Okay, and he also says that grounding is different from causality.
Right. Causality is a relation between events in the world, but grounding is a relation between truths.
Okay, so it's like a logical relation.
Right, and he gives all these really interesting principles for grounding. He says that only true propositions can stand in the grounding relation, and that every true proposition has a unique ground, and that a ground can consist of a set of truths.
And he also talks about formal grounding.
Yeah, formal grounding is when a proposition is both deducible from and grounded in another proposition.
Okay, so it's like a special case of grounding.
Right, and he also introduces this notion of basic truths.
What are basic truths?
Basic truths are truths that have no grounds. They're the ultimate foundation of knowledge.
Okay, and he thinks that there must be at least one basic truth.
He actually thinks that there must be more than one.
Okay, and he doesn't think that basic truths have to be self-evident.
Right. He thinks that they can be really complex and obscure.
Okay, and then non-basic truths are grounded in basic truths.
Right, and he thinks that the grounding relation can form these chains or trees. So one truth can be grounded in another truth, which is grounded in another truth, and so on until you get to a basic truth.
Okay, and he has all these really interesting conjectures about how grounding works.
Yeah, he thinks that the grounds of a truth are always simpler than the truth itself, and that the grounding relation is never redundant.
Okay, so it's a really elegant and powerful theory.
Yeah, and it's been really influential. It's been picked up by contemporary philosophers like Roski, who sees grounding as a way of explaining why some deductive arguments are more explanatory than others.
Okay, so that's Bolzano's logic in a nutshell.
Yeah, we've covered a lot of ground here.
And it's clear that he was a really important figure in the history of logic and epistemology.
Absolutely. He introduced a lot of new ideas that are still being debated today.
And he was really ahead of his time. Yet a lot of his ideas didn't really get